Alrighty, here we go. Part A. It says write the degree of each polynomial in the line. And what we're doing, we'll start with C because that's the easiest one. The degree is the highest exponent. And the highest exponent on this sucker is 9. So you just write the highest exponent. Now, normally, in something like if I had like 5x to the 4th plus 3x to the 7th minus 8x squared, you pick out the highest degree, bam, the highest degree is 7, something like that. But when you have multiple variables in here, you've got to think about all those exponents in there. And it's kind of weird. It's kind of like a one-time thing. It's the only time you're going to do this. So if I look at A, I've got to see how many exponents I have here. I have 10 exponents there. I have an 8 and a 2. I have 10 exponents. Over here, I have a 1 and a 6. That's 7. So the highest degree I have, and a 0 here, the highest degree I have is the 10. So it can kind of be wacky when there's more than one variable. It's kind of a weird thing that you don't always do. Over here, I've got an x to the 7th, y to the 1st, so my exponent, my highest degree is 8 there, or my degree there is 8. And over here, I have x to the 1st, y to the 9th, so my degree is a 10. That's higher. So my highest degree is a 10. All right, so not something you're going to do every day, not something I want to really spend a lot of time on, but that's how you do it. Over here, the difference, so that's subtraction of polynomials is always a polynomial. A, always. If you start with a polynomial, you'll end with a polynomial, and that works for subtraction, it works for addition, it works for multiplication. It only doesn't always work for one thing, and that's division. Division is the only time we're going to have a sometimes. All right? And you'll see why. I think there's a situation later where it'll give us something that's not a polynomial. So that's only with division. All right, all right. Up next, we're looking at question number 2, and 3. Question number 2, write your answer in standard form. We're going to simplify. And now in class, you guys pointed out that it is addition. All right, that's super important. I don't want to see you multiplying when you should be adding. So addition, and all you got to do with addition is combine those like terms. So that means I'm going to look for the highest exponent first. I see an x cubed, I see another x cubed, and I'm going to combine those. So with your calculators tomorrow, or without a calculator if you're big-brained, we're going to have negative 5x cubed plus 4x cubed. So negative 5, combine it with a 4, you should get negative 1x cubed. All right, and then we'll go to the next highest exponent. All right, our next highest exponent is going to be an x squared. And I do have an x squared here. So, but I don't have any like terms for it, so I'm just going to write negative 3x squared. Boop. Next. So my next highest is going to be an x to the 1st. So I have a positive 8 and a negative 10. When I combine those, when I add those together, 8 plus a negative 10, 8 minus 10, negative 2x. So we're just combining those. All right, and last up we have our constants, and that's a negative 12 and a positive 3. Add them together, negative 12 plus 3 is a negative 9. All right, guys, so please do use your calculators. Do be careful with your negative signs. Since we just did number 2, we're going to jump on down to a similar problem, number 5. I know I'm skipping around, but that's because they're similar. Write an expression for the perimeter. Now, perimeter means adding all the sides. So I'm going to go around here. I'm just going to add them all up. Now I'm going to show you a quick and easy way to do this. Just like we did on the last problem, I'm going to start with the highest exponent. I got a b to the 1st power. I've got a constant. Hey, I got a b to the 2nd power. That's my highest exponent, and it doesn't have any like terms. There's no other b squareds. So I'm going to start with that 2b squared. All right, next up, I'm going to go around and add up all the b's. All right, I've got a 4b here, a 3b here. Let me write those down. I got a positive 4b. I got a positive 3b. And it looks like another, that was a positive 3b. So I'm going to combine all those like terms, just going to add them all up. All right. And I should go ahead and do the constants too while I'm at it. The constants, I got a positive 5 and a negative 8. A positive 5 and a negative 8. All right. So we're just going to combine all those like terms. 2b squared didn't have any like terms. The b's, there was a 4b, 3b, 3b. So I'm going to add them all up. How many b's do you see? 7 and 10. 4 plus 3 makes 10. And then add our constants. 5 plus a negative 8. Negative 3. All right, guys. So again, we're just adding. We're just combining like terms. Cool. Now we're going to do the other two that we skipped. Saving those for last because they are both subtraction. So I know they're subtraction because I see the minus sign. So I know when I see that, I've got to distribute that negative sign to everything behind it. So it's really going to be a negative 8x plus 3. You know what? I don't need parentheses anymore. After you distribute that negative sign, you don't need parentheses anywhere. So I'm distributing the negative sign. That's going to turn that into a negative 2x squared. It's going to turn this into a negative, so a positive 8x. And a negative times the 2 is going to make a negative 2. So now once we do that, it becomes just like the last two problems. We combine like terms. Find the highest degree. Hey, highest degree. And there's no other like terms with it, so next. All right, next highest degree is the x to the first power. There's a negative 8x and a positive 8x. Now, I don't need to write 0x. I'm just not going to write anything. Okay, so I'm going to cross them out because it's a positive 8 and a negative 8. They do cancel out. Not going to write 0x. Don't need that. And we're going to move on to the constants. I got a positive 3 and a negative 2. 3 minus 2 is positive 1. All right. So I'm looking for negative 2x squared plus 1. I'm looking for C. I bet if I would have made a mistake, it would have been some of those other answers. All right, last up. Oh, blah, 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 blah. Oh, there's a key word here. In this one, the key word is how, or the key phrase is how much more. So like I talked about in class, if I've got $5 in my pocket and Prince has $12 in his pocket, how much more money does Prince have than I have? I've got $5, he's got $12. To find out how much more, that is subtraction. We would say his $12 minus my money, my $5, he's got $7 more than me. So to determine that, we have to use subtraction. So how much more does it cost to make toy tanks than toy soldiers? So it'll be toy tanks minus toy soldiers. So I got to go back in the problem and find the toy tanks. Toy tanks is represented by this. So I'm starting with that. 25 plus T. Toy tanks minus toy soldiers. Toy soldiers is represented by this. So look how I'm using parentheses. That's important. That's a important thing to do so I distribute correctly. Because it's subtraction, I have to distribute the negative sign to everything behind the parentheses, just like we did in number 3. All right. So when I do that, it's going to say 25 plus T minus 6.5T. And then remember, I'm distributing this negative to the 12 as well. So it's going to become a negative 12 or minus 12. So my plus sign kind of looks like a minus sign over here. My plus sign kind of looks like a T over here. So careful with those. All right. So when I do this, I'm combining like terms. Again, I start with the highest degree. That's a T to the first power. So I've got 1T minus 6.5 T's. 1T minus 6.5 t's. So when I combine those, 1 minus 6.5 is negative 5.5. Negative 5.5 what's? T's. Remember, you can use the calculator tomorrow. And then my constants is a 25 and a minus 12. 25 minus 12, I think it's 13. All right. So the toy tanks cost this much more. I don't know what that means. All right, guys, that's everything. If you get confused, please come see me during lunch or before school, or go see somebody else. That's cool too. Thanks.